All right, so we have four sections we're going to go through today, but they're pretty quick sections. For this 5.4, we're just going to look a little bit more in depth at some of the impacts that agriculture can have on the environment. Our learning objective today is going to be to describe agricultural practices that cause environmental damage. And for your FRQ, you're going to describe environmental concepts and processes. So the first thing we're going to talk about is monocropping. So that's just growing one single species. Most commonly, it's done with corn, wheat, and soy. And when I say growing one single species, I don't mean like you're growing a couple of rows of corn in your garden. I'm talking about like huge quantities, just like never-ending fields of the same crop. So this is pretty efficient for the farmers. It's easy to harvest. It's easy to apply pesticides and fertilizer when everything's the same. It's easy to know how much water is needed. But this is going to decrease the biodiversity present, and it's going to mean that whatever crop we planted, it's going to be much more prone to pests. I mean, imagine if you're a pest and you're a little bug and you love, corn, that's your preferred food source, and you go and you lay your eggs in this field, and then when your babies hatch, they're going to be surrounded by nothing but the food that they want to be surrounded by. So more prone to pests. Now we also will see some increased soil erosion with this. So the crops get all harvested at one time. That soil is left bare. We don't have any roots in that soil or the windbreak from the actual plants. So we're going to have more erosion happening. And then obviously this is going to decrease habitat diversity because we're going to have just this huge area of all the exact same thing growing. So we're going to lose habitat for things like pollinators, like our bees and wasps. We're also going to lose habitat for things that could have been maybe a predator to some of these pests, but now they're not going to live there anymore. Then we have tilling. So tilling is just taking usually machines and breaking up the soil. This is going to make it easier to plant. It's going to loosen the soil up some so the roots of the plants are able to grow easier. But this definitely is going to increase erosion. So as that tiller runs across the field, we're loosening up that topsoil. We're breaking up whatever roots were left from the last harvest. And you can even see in this picture, like some of that soil already getting blown away. So as we do this, as we break that soil up, we're going to lose a lot of that organic matter in the topsoil nutrients over time. So in the short term, tilling is going to save money because it's quick, it's easy, but over time, we're actually going to see the quality of our soil decreasing. So in the long term, this could actually decrease profit unless we treat our soil to get back some of that organic matter and some of those nutrients. Now, as you see that soil kind of blowing away, we can also have increased PM, which is particulate matter in the air. This can be a respiratory irritant if you've got something like asthma or bronchitis. And this could also increase sediments in nearby water, which increases that turbidity. Remember, the turbidity is just the total amount of particles suspended in the water. So turbidity can have some pretty major negative effects. If you look at this picture here, you can see if we have a no-till ecosystem, we tend to leave some of the crop material behind that we don't want. And so you can see those roots are still all in that soil. We've got our worm burrows still in the soil, so we're really anchoring that soil down. But in a tilled ecosystem, this compacted area right here, that's going to be very easy to blow away and to be eroded. All right, slash and burn. So in slash and burn, we're actually going to cut down an area of vegetation that we want to use for agriculture, and we're going to burn all of the vegetation that was left behind. So this is good for the farmers because when you burn it, it does return nutrients that were in these plants to the soil. So slash and burn creates very fertile soil for agriculture, but it does cause deforestation where we're going to see that loss of habitat, biodiversity. Those trees are not there anymore to absorb that carbon dioxide or sequester it. And then those trees, like we've talked about, are going to filter a lot of air pollution. So that benefit is gone now as well. And then the burning part, when we burn the trees, we're going to be releasing carbon dioxide, carbon monoxide, nitrous oxide, which are all greenhouse gases that are going to lead to that climate change we've talked about. This can also increase particulate matter in the air from the smoke. And then this also lowers the albedo of the area, making the area warmer. If you look here, you can see that we've got the trees, we've got the burnt area. So that forest is going to be able to reflect a lot more light and stay cooler. Whereas over here, all that light is going to be absorbed, turned into infrared energy and heat, and dry out the area. All right, then we've got our inorganic fertilizers. So it's really important that you understand the difference between a synthetic and an inorganic fertilizer and an organic fertilizer. So these synthetic fertilizers are fertilizers that we are making ourselves. So they're not coming from like compost, manure, things like that. So they don't return any organic matter to the soil. And remember that organic matter is going to help with the water holding capacity. And since we're not putting any organic matter back in there, we're not adding any soil decomposers to help with breaking down and recycling those nutrients. Another problem we see with these synthetic fertilizers that we don't see as bad with our organic fertilizers is what we call leaching. So these synthetic fertilizers, they're going to have all kinds of nutrients in them, like ammonium, phosphates, nitrates. And with leaching, what we see is that ammonium, that NH4, when it's in the soil, it's going to get turned into nitrite and then nitrate. And that nitrate is very easily washed away. So it could end up in groundwater, or it can end up in surface water as runoff. So if it ends up in our groundwater, that's going to contaminate it for drinking. And then we've talked about eutrophication, guys. I feel like 1,000 times, okay? So we can also end up with that eutrophication. Now, I want you to understand that even though we're talking about these synthetic fertilizers causing all these bad things, I do want you to understand that our organic fertilizers, like our compost, can still do this. Like cause eutrophication and cause contamination of drinking water, but it doesn't happen as often, and it's a much slower process because with these synthetic fertilizers, we're just going out and just dumping huge amounts of these nutrients onto fields, way more than the plants can even use. But with our organic, our organic fertilizers, they're going to release these nutrients much slower. So the plants are actually able to absorb them and use them before they are leached and washed away. So your practice FRQ here is to explain one disadvantage of using inorganic commercial fertilizers. And then we're going to jump right into irrigation. All right, the next section we're going to go into is irrigation. Irrigation is super important when it comes to this unit because it allows areas that were once too dry to become arable. So remember, arable just means that we're able to farm them. So we're going to look at, in this, I know this looks like a lot, but it's really not as bad as it looks. We're going to be able to describe the different methods of irrigation, and then we're also going to talk about the benefits and the disadvantages of these different methods. And so your FRQ practice today will be to describe disadvantages, advantages, or unintended consequences for potential solutions. So let's jump right in. We've got quite a few to talk about here. So we've got furrow irrigation first. So essentially with this, we go out into our fields, we dig a trench right along our crops, fill it with water. That can then seep into the soil. It's easy, it's not expensive. The water seeps into the soil slowly, so the plants get just what they need. But this is very inefficient. It's only about 66% efficient, so that means the other 33% is getting lost as either runoff and evaporation, and that's going to be a big problem if you live somewhere where water is expensive or where water is hard to access. All right, our next irrigation method we're going to talk about is flood irrigation. So for this one, they actually are going to go out and flood the entire field. It's very easy to do, but it's pretty disruptive to the plants. There's only certain crops that this is going to be suitable for, things like rice, cranberries, because this can waterlog the soil and essentially drown the plants. This is a little bit more efficient than our furrow irrigation, but still losing about 20% of our water. Then we have spray irrigation. So this one's pretty efficient. There's a lot less water loss there than when we look at flood or furrow irrigation, because we're going to take groundwater or surface water and we're going to pump it into these spray nozzles. But this is a pretty expensive method because, number one, farmers have to pay for the actual equipment themselves and then for the energy to get the water from either the groundwater or surface water into the equipment to then be able to spray it. And then we have drip irrigation. This is the most efficient. We have over 95% efficiency here, so we're losing very little water. Essentially, it's going to be these little hoses spread throughout your crops, and there's going to be little holes cut or drilled into those hoses that are going to allow that water to slowly drip out right at the plant. It's going to avoid waterlogging. It's going to conserve water. It's going to help prevent soil salinization that we're going to talk about in a little bit. But it's very impractical. I mean, especially if you're talking about like those monocultures where you've got those giant fields, farmers aren't going to be able to go out and lay, miles and miles and miles of this hose. So this spray irrigation tends to be one of the most common. So let's talk about waterlogging a little bit. So you can actually overwater. It's going to saturate the soil. We've already talked about soil having those little pore spaces in it. So when the water, when it's overwatered, those little pores, instead of being filled with air and water, it's actually going to be filled completely with water. So that doesn't allow any air to reach the roots of those plants, so the plants can't take in the oxygen they need. So this can either stunt plant growth. In some plants, it can even kill them. So some solutions there would be things like drip irrigation to avoid overwatering, soil aeration. So aeration is just the process of like taking little cores, I guess, from the ground. You can go through and, I mean, honestly, if it's a small area, take a pitchfork and just kind of stab it in. There's for larger scales, there's machines that do this. So that's going to allow the air in. It's going to allow the water to drain through the soil. It's going to allow for those roots to grow a little bit deeper. So with salinization, that's going to be the process of salt building up in a soil over time. And it's going to be coming from our groundwater. So groundwater naturally has small amounts of salt in it. It's normal. It's supposed to be there. But when we use that groundwater, the salts end up on the soil and the water evaporates. And the water evaporates and leaves that soil behind. So over time, as that salt it gets left behind on the soil, it can build up, and eventually reach levels that are toxic to plants. It can dehydrate their roots. It can prevent growth. So some, once again, solutions, drip irrigation by providing that water directly to the plant site instead of all over the field. It's going to decrease the overall amount of water used, so you're not going to have as much salt. Soil aeration, so that's going to allow the salt to travel deeper into the soil and kind of disperse out instead of just being left on that top layer. We can take fresh water and actually flush the soil with water to be able to get that salt out, and then switch to a freshwater source like a lake or a pond or whatever to avoid or lessen the amount of salt that is ending up in the soil. So when we talk about irrigation, we're talking about how we use water. So we've got this here in the middle of our ag unit. So it should be obvious that most of our water is going to be used, 70% of it is used for agriculture. The other two main categories are industrial, so that's talking about things like coal-fired power plants, metal and plastic manufacturing. That's going to be 19%. And then we've got municipal, so that's what you're using in your house to take a shower, to drink, when you flush the toilet, when you're brushing your teeth, whatever. And then our agriculture, that's going to be used for our livestock, to water our livestock, or irrigation to water crops. So groundwater is just water that's stored in the pore spaces of permeable rock and sediment layers. So when you look over here, you can see we've got something called a water table. So above that water table, those pores between the soil or in the rock are filled with a mixture of air and water. But once we get down here into our water table, those pores are completely filled with water. So those are going to create what we call aquifers. These are going to be usable groundwater deposits for humans. We've got unconfined and confined. Our unconfined are going to be able to be replenished much easier. So we're going to see both of these being replenished by groundwater recharge, which is just going to be that rainwater working its way down through the soil. Now those unconfined aquifers, so you can see it doesn't have a solid layer of rock above it. It's just got like some soil there. That's going to recharge very quickly. Most people who have wells that are dug into unconfined aquifers. But our confined aquifers, they're really surrounded by rock almost on all sides, almost everywhere. So those confined aquifers are going to recharge much slower. So these are going to be able to hold water much longer, but they're also going to recharge much more slowly. So they can be safer water for us to drink, but they're easy to use up. We're able to drill out of these a lot quicker than they can refill. So those aquifers can be depleted in a couple different ways. The first one is through what we call saltwater intrusion. So as we pump water out of those aquifers that are near coasts, the water table is actually going to have less pressure in it, which is going to allow salt water to seep into that groundwater. And then we also have something called the cone of depression. So whenever we have a water table being lowered by excessive pumping, that's going to deplete water and dry out nearby wells. So you can see we've got our water table here. And as that water table gets used up, we start to see these wells no longer able to access that water because they're in that shallow area. So your practice FRQ here is to describe how soil salinization occurs, propose a solution to prevent or remediate soil salinization, and then identify one disadvantage of the solution you propose. All right, 5.6 is pest control methods. So we're going to talk about different ways that we try to control pests and some of the downsides of those. So you can see like here when we have these like flyovers, that's going to reach a lot of unintended things. So like if we're just trying to get rid of like a caterpillar, but we're spraying this everywhere, other things are going to be affected. And then we can also see resistance and superbugs being created because of pest control methods. So our learning objective here is to describe benefits and drawbacks of different methods. And then for your FRQ, you're going to make a claim that proposes a solution to an environmental problem in an applied context. So let's get right into it with what is a pesticide. So that's going to be a chemical that's toxic to pests. Each pest has its own specific pesticide. So rodenticides are going to obviously kill rodents, fungicides kill fungi, insecticides kill insects, herbicides kill plants. So what we see here, though, is that we see pests becoming resistant to pesticides when pesticides are being overused. So we know that most things have genetic diversity. So when we have that biodiversity, some pests are going to have traits that make them resistant to that pesticide. So what we see is that pesticide is actually um, speeding up the evolution of those pests. It's artificially selecting the pests that have resistance and it's killing the rest of them off. So only the resistant ones get left, the resistant ones reproduce, and then the whole next generation is resistant. And that creates what we call this pesticide treadmill, where we're always having to develop new pesticides. So we develop a pesticide, we apply it, most of them die, but some survive. The ones that survive um, have offspring, and then that proportion of those resistant ones just increases over time. And then we go back, try to use that same pesticide, and it doesn't work. So then we have to avoid our crops getting infested with pests, we have to make a whole new pesticide. So with this, what you can see is even those like genetically modified crops that we've talked about, that BT corn, this is showing you the million hectares of BT corn planted and then the number of resistant species. Remember that BT corn produces like its own little insecticide or pesticide. And so you can see as we've started to plant more and more and more of that BT corn, we're seeing more and more and more resistant species to that pesticide that corn is able to create. So let's talk about how GMOs kind of affect this whole pest thing, okay? So we've already kind of talked about that BT corn. So bacteria, genes that are going to make those BT crystals are placed into the corn. So it makes that corn actually toxic to pests. Another example would be Roundup Ready crops. So they're genetically modified to be resistant to broad herbicides like Roundup. So that means farmers can go out, spray all this Roundup to kill the weeds, but the crops will survive. Here's just another diagram showing you that BT corn. Okay, so it's got that bacterial gene in it, and so when the caterpillar now eats the corn, it's going to die. So when we look at GMOs and pesticide use, two things can really happen. It can either decrease pesticides that we're using, so that BT corn actually decreased the amount of insecticide that farmers have to use because the corn's making its own insecticide. So they're already paying for the corn seed that has the specific gene in it. So you can see they're not having to pay for insecticides. You can see that number going down, the amount of insecticide used, as the amount of BT corn planted goes up. So that would be an example of that inverse relationship. However, it can also increase the amount of pesticides used. For example, our Roundup Ready crops, they've actually increased glyphosate application per year because the crops aren't harmed by it. So more and more Roundup is being sprayed to kill the weeds to prevent any competition. Don't forget that those GM crops are all genetically identical, so there's no genetic diversity in the population. They're all clones of each other. So if there is a disease or a pest that's going to affect that GM crop, then they're all vulnerable. There's no chance of mutation and adaptive traits. We've already kind of looked at this picture once, so I'm not going to go over it a lot. But just remember that GMOs are going to greatly reduce our genetic diversity. So your practice FRQ, describe one economic advantage and one economic disadvantage of using genetically modified crops. And then the last section for today is going to be covering meat production methods. So we're going to look at two main types, which are going to be CAFOs, which are concentrated animal feed operations or feedlots. And then free range grazing. So we're going to be able to identify different methods and be able to describe the benefits and the drawbacks of each type. So let's start here with our CAFOs. All right, so we're going to start with our CAFOs. So like I said, concentrated animal feed operations. These are also called feedlots. This is where we're going to see a lot of very densely crowded animals. They're typically fed a grain, typically corn, to raise them as quickly and as cheaply as possible. This maximizes land use and profit, so we're going to be getting the most meat production per unit of area. And that in itself minimizes the cost of meat for consumers. So all positives so far. However, a lot of times in CAFOs, these animals will be given antibiotics or growth hormones to prevent disease outbreak and speed up that meat production. Understand not every single CAFO uses antibiotics and growth hormones, but a lot do. And then obviously when we've got this huge amount of animals in one area, they're producing huge amounts of waste, which can contaminate surface and groundwater. These animals are also going to produce a lot of carbon dioxide and methane and nitrous oxide, which are greenhouse gases. So going back to that waste. So a lot of times what we'll see at CAFOs are these manure lagoons. So these are large open pits where you can kind of see these drainage pipes coming into this little like storage pond, and that's going to be manure. So that waste is going to contain ammonia, hormones, antibiotics, can also have fecal coliform bacteria or E. coli in it. And what we can see happen is if those lagoons aren't cleaned often enough, and a heavy rain comes, it can flood those lagoons. And then that water is actually going to make its way out of the lagoon into surrounding nearby surface water and groundwater. So some bad things about that. E. coli, number one, in larger amounts, it's toxic to humans. That ammonia can lead to eutrophication. And then if antibiotics and growth hormones are used in large quantities, those can also alter the endocrine system of humans. So some things that can also happen would be denitrification of ammonia in that manure. That's going to produce nitrous oxide, which is going to be an extremely powerful greenhouse gas. But what we can do to try to avoid this flooding situation that we have here would be emptying these lagoons out more often, burying them in landfills, and then taking whatever is dried and left and creating organic fertilizer pellets from it. So let's switch over to free range grazing. So typically our animals, we see this most with cows, are going to graze on grass. They're going to grow at a natural rate, no hormones, any of that. They're much more dispersed, so disease doesn't spread as much. They don't require corn to feed them because they're out here and they've got lots of browse available to them. Waste gets dispersed as they're able to cover these larger amounts of land. And so that waste actually gets to act as a fertilizer instead of just building up in those lagoons. Some downsides of this, it does require more total land per pound of meat produced, which is going to make it more expensive. But another positive is that we can use a lot of land where it's too dry for most crops to grow. Like we wouldn't see crops like corn or wheat being grown in these areas because it's too dry, but those grasses will grow there. So one of the big problems we see here is overgrazing. So we just have too many animals eating in a specific area for too long. So that leads to the removal of all the vegetation. You can see how different those two look, which is going to increase that erosion. As those animals walk around, they are large animals. They can compact the soil, which is going to decrease that water holding capacity, which just creates that feedback loop of more and more and more erosion. And these two things together, where we start to lose the plant life and then we start to see the soil compacting, can lead to what we call desertification. So that's where we're going to have plants killed by overgrazing and the soil compacted so much that it cannot hold enough water to support plant growth. And if we want plants to grow there again, we will have to go out and remediate the soil. So one way to save or stop this from happening is through what we call rotational grazing. So we're going to move our animals around periodically, kind of fence them off from certain areas. And so that is going to be good because we're actually going to see an increase growth of grass by distributing the cows in a particular way, keeping them out of an area for a while, putting them in an area, out of an area, in an area. So you can see if we've got this picture here, if the cows cut this grass down to 2 inches every single week, we're not able to grow much of a true root system there. Every 2 weeks, we can start to see those roots growing even better. And every 4 weeks, we've got a ton of plant growth there. And so going back to this real quick, clipping grass back to size where growth is most rapid. Down here, because we're not letting the roots grow, we're going to see some pretty slow growth. But if we let plants grow too tall, they also stop growing. So we kind of get them in this area where the plants have created these really nice root systems and are able to grow really quick. So we get the cows out of there. Don't let them eat in that area, and then we'll put them back in that area, let them cut it down, move them away, let the grass regrow, and it just really increases the rate of vegetation growth. So when we talk about how efficient our food is, producing meat for humans to eat is way less efficient than producing plants when we talk about everything from energy to land to water use. So for energy, when you think about it, if you're going to grow a crop, that's going to require energy to do that. So now we are going to need energy to grow the crops, harvest the crops, and feed the animals. Plus, we're going to need energy to bring that water to animals, energy to house animals, energy to slaughter and package animals. So when you look at the energy required to produce 1 pound, to make 1 pound of beef, we're using about 32 kilowatt hours per pound. And corn is way down here at like maybe 1 kilowatt hour per pound. When we look at land, so you need all the energy needed to grow the plants to feed animals, plus the room the animals take up. So you've got to have land to grow crops to feed the animals, and then land for the animals to live on. So when you look at usable protein per acre of farmland, so if I have 1 acre, I can maybe get about 20 pounds of beef out of 1 acre, okay? But when we start looking at things like soy, that's 356 pounds per acre. So much more usable protein per acre when we look at our plants. And then water. So just like we need all the energy, we need all the land, we need all the water. So we've got to have all the water that the crops need, plus the water the animals are going to drink. So it's very inefficient to have a very meat-heavy diet. We can even go straight back to the second law of thermodynamics, where we're losing energy as we go through that trophic pyramid. So by taking the energy in the plants and giving it to the animals, we're losing energy there. And then we take the animals and we eat them, we get the energy from them. But we would actually be able to get the most energy just from eating the crops directly ourselves. So your practice FRQ, explain an environmental benefit of eating a plant-based diet rather than a meat-based diet using the data below.